Qualitative analysis. So in our lesson today, we are going to have a deep and thorough discussion of qualitative analysis on inorganic chemistry. So what is qualitative analysis? This is a series of tests that require a student to test and identify cations and anions in inorganic analysis. So a student is expected to follow the instructions carefully, record all the observations correctly, and lastly, make the right inferences. So the key guide here, of course, is the proper use of the reagents provided. Now, these tests have been kept as simple as possible to enable the learner to understand what he or she is doing. And yes, I actually used the term simple because I firmly believe that out of the three papers, it's very easy for a student to score good marks in paper 3 as compared to the other two. Now, the tests carried out in inorganic analysis focus on the detection of the following ions. Now, before I proceed with the individual tests, I would like to mention a few general tips. Of course, as we move along, I'll be discussing more tips, observations. In qualitative analysis, what are you looking for? Number one has to do with what you're seeing. What is the color of the product that has been provided? Was a precipitate formed, and if so, what is its color? Did you carry out filtration? And if you did, what is the characteristic color of the filtrate and residue? Was a gas produced? If so, what are the characteristics of the gas in terms of color and smell? What about the effect of the gas on moist blue and red litmus papers or on a burning or glowing wooden splint? Effervescence, are you seeing any bubbling or fizzing? Guys, all of these are very, very important for you to note. So whenever you do a practical, you have to be very, very keen not to miss out on anything. Another is, what is it you're hearing? Now, sadly, this is something that a lot of students tend to miss. When it comes to observations, observations can also feature the sounds you hear. For example, when you hit lead-2 nitrate, what happens is that it burns with a cracking sound. That is something you need to note in your observations. What about hydrogen gas? Hydrogen gas extinguishes a burning splint with a pop sound. So all of these are things that you need to note. Lastly, what are you smelling? Is the gas being produced odorless or does it have a choking, irritating smell? What about if you have a compound that has a pleasant smell? I'm sure by now most of you have been taught about esters. Esters are compounds that are formed when you react an alkanol with an alkanoic acid. So you get a compound that has a pleasant smell. This smell is something that you need to note. So when recording your observations, there are a few common mistakes that students tend to make. Number one, writing meaningless words. So some students on carrying out an experiment will see no change. And so would write down no change or no reaction or no observation. This, my dear students, is wrong. As a student, before you carry out a particular experiment, you should always have at the back of your mind an expected observation based on the reagent you're using. Okay, let me give an example. If you're using barium nitrate solution, this is a solution that is used to test for sulfate, sulfide, or carbonate ions. Before using this, you should already know that there are two expected observations that can be there. Either you're going to get a white precipitate being formed or no white precipitate formed. And the reason for this is because barium sulfate, barium sulfide, and barium carbonate are insoluble salts. So if they are formed, you're getting a precipitate, a white precipitate specifically. So before you do this test, you need to have all of this at the back of your mind. So stories are you're not seeing any reaction, you're not seeing any observation. You should always have an observation and it should be the correct one. Now, another is wordy answers. Avoid lengthy observations whereby you use so many words to express yourself. Don't do that. In chemistry, we expect you to be direct and concise. Now, what happens is that when you use so many different words to explain your observations, why would you do this to yourself? You compromise the quality of your answer. So please don't do this. Another point of note, has to do with color changes. Now, when you have changes in color, actually, you may either have changes in color or not. So, if you don't have a color change happening, what you're supposed to do is you're supposed to state the specific color that has not changed. Giving an example, let's say you're using acidified potassium manganate 7, which is purple in color. Now, if the color persists, the purple color persists and does not change, how are you supposed to write your observation? You're supposed to write it as such. Purple potassium manganate 7 color persists. Now, if you do have a color change, you're supposed to indicate both the initial color and the final color. Going back to our example of potassium manganate 7. For example, it has been decolorized. How are you going to state this as your observation? You're going to write it as such. Purple potassium manganate 7 turns to colorless. Or you can write it as decolorized. Either is correct. But you have to mention the initial and final color. If you write your observation as such, potassium manganate 7 solution is decolorized, that is wrong. Moving on to the next one, wrong terminologies. This is whereby you're using the wrong terms, and of course, you're going to be penalized fully for this. So, for example, if you have a white precipitate, you should write it as such and never use the term cloudy or milky precipitate. If you have a colorless solution, it should be indicated as such and not a clear solution. When writing down your inferences, these are the conclusions you come up to based on your observations. You should always write the suspected ions using the correct symbols and charges and never ever with words. Now, I tell my students this. There's no shame in not knowing the formulae of a particular radical or a particular ion. So if you're very, very weak in this aspect, what I would recommend for you is to create spelling worksheets for yourself. You know those spelling worksheets that are usually given to kindergarten or nursery students? They have to repeat again a certain word again and again and again until they memorize it. That is what you should do for yourself. You know, on those days when you are just tired, you know, you're not in the mood for learning, but you still want to do something productive, get your spelling worksheets out if this is where you're poor at. So write hydrogen carbonate 10 times, move on to ammonium ions, to nitrate ions, and then come back and tell me after doing this 50 times whether you're still not going to know the formulae. Now, when writing these ions, you know, in your inference, please don't add any other ion if it's not the correct one. So just write the correct ones and stop. Now, this is because if you write any other ion and it's not supposed to be there, so you're going to be penalized for the presence of the contradictory ion. So actually, less is better here. Last one. When doing your practicals, work systematically in the order provided, writing down your observations and inferences as you go along. However, if you are unable to make sense of a particular reaction, kimeumana, like you are getting this observation, but unafikiria and you can't make out what the inference is supposed to be, leave it. Record your observation and just leave it. Move on to the next test. Don't waste your time. At the end, you should make time to go over your work, correct any mistakes, and check for anything you have missed.